I'm just going to develop the special right triangle side relationships, and to do so I'm going to start with the square and the equilateral triangle. And so when I start with the square, I'm going to label each side as an x and figure out what the hypotenuse is in terms of that. So by using the Pythagorean theorem, we'll just call that a box. This side is the box, and so by combining like terms and squaring, taking the square root of both sides, you're going to see that that hypotenuse is equal to the square root of 2 times x, and positive. So you know that that third side is square root of 2 times x. This is a relationship between the two sides. If you didn't leave the x's in, you could think about these in terms of 1, 1, and square root of 2 as the three sides. Doing the similar activity in the equilateral triangle, labeling this as side x. You could say this is 2x because it's an equilateral triangle, and that would be x as well. And the idea here is to get the leg. So again, x, by using the Pythagorean theorem, x squared plus your box squared equals 2x squared. And by solving for your x squared, you get square root of 3x. And so this third side is square root of 3x. And again, what you could do is think about this in terms of just numbers: 1x, 2x, and square root of 3x. Now, when you do problems involving special right triangles, I like to just focus on the sides: 1, 1 square root of 2, and 1 square root of 3, 2. And these would just be the legs. This is the short leg, and that's the long leg. So I'm going to concentrate on names of these, and the short leg should be the one that's referenced because it's only an x, and it's easy to evaluate based off of that one to find the other two sides. So this is going to be the long side, long leg, and the hypotenuse. Doing these problems down below, I now can just make up numbers and go around the triangle, such as if I have a 4 here, I know that by listing 1, 1, square root of 2, to go from square root of the hypotenuse to the leg, I'm going to divide by square root of 2 to get back to 1. Or by going from the leg to the hypotenuse, I'm going to multiply by square root of 2 to get the square root of 2. So you would multiply to get to the bigger side, you would divide to get to the smaller side. So I'm going to take that 4 and divide it by square root of 2. And when you simplify, you get 2 square roots of 2. And that's what you have for both of these. And that makes sense because if you multiply this by square root of 2, you're going to end up with that. Also, you could start with 10 and 10. Those are the same side, and this is going to be 10 square roots of 2. By multiplying to get to a bigger side, you multiply by square root of 2. Here's your 30, 60, 90. The ratios again: 1 square root of 3, 2. And going from one side to the next, if I started with a 5 here, this would be multiplied by square root of 3. So this is just 5 square roots of 3. And this would be multiplied by 2. So that's just going to be equal to 10. On the third one, we'll make it a little bit more challenging. And I'm looking at maybe creating the hypotenuse. Well, the long leg, let's say, is going to be 6. So going from long leg to short leg, I would divide by square root of 3 and simplify. So I'm going to multiply top and bottom by square root of 3, and it's going to be 6 square root of 3 over 3, which is 2 square roots of 3. Makes sense when you go the other way by multiplying by square root of 3. And then the hypotenuse is doubled with the short leg, so that's 4 square roots of 3. That's a quick lesson on the 2 special right triangles. One special right triangle is known as the 45 degree, 90 triangle because these are both 45 degrees. And the other triangle is the 30 degree, 60 degree, 90 degree. And that's seen here because this is equilateral triangle. You have 60 degrees and you have 30 degrees. And looking at the ratios and either multiplying or dividing, getting to the bigger sides or smaller sides.